Hey everyone, in this video we are going to learn about type conversion in JavaScript because this is a really important topic in JavaScript and it makes up a good amount of interview questions and gotchas. We will understand what type conversion is and how JavaScript does the type conversion so that it does not remain a mystery to you and you know where to look for information in case you are really concerned about how that particular type conversion happened. So you will understand the basic building blocks of how this thing happened. So without any further ado, let's dive right in. Before I start the video, make sure you click the subscribe button and give this video a thumbs up in case you want to see more such stuff in the future. So let's understand what type conversion is. So type conversion deals with converting one data type into another data type so that JavaScript can carry out the operation without running into error. So this is JavaScript way of being fault tolerant and forgiving, that it will try to convert two different values into something where it can actually do the comparison or carry out the operation. So very common such operation is 1 double equals to 1. So here you will receive the answer true because JavaScript thinks that the user is trying to check whether 1 is equal to 1. It takes into account that the user might be comparing oranges to apple, but I will try to convert these two things into their equivalent values where I can actually do the conversion. This thing comes under type conversion. Again, if we do true plus 1, again the answer is true, which means that some sort of type conversion is happening. This true thing is getting converted into its numeric counterpart, which is 1, and then we are getting the answer 2. So let's talk about the guiding principle for type conversion. You need to memorize one thing, that everything gets converted into either a number or a string ultimately. Now here ultimately should be noticed because there might be certain intermediate stages where the algorithm is going to go through, and ultimately it will arrive to a point where every single value is converted into either a number or a string. There is no third option. So how does JavaScript know whether it needs to convert anything to a number or a string? There are certain operators that prefer numeric data types. There are certain operators that prefer string data types, and then there are operators which do not prefer anything. So let's start with operators that prefer numeric data types. So let's suppose we are doing something like 1 into 3. Here the answer is going to be 3 because multiplication is an operator which only prefers numeric operand, which means that everything that is involved in a multiplication operation will be converted into numeric values. So this string value is getting converted into a number. And now if we do something like e multiplied by 3, we will get not a number because this e will get converted into its numeric counterpart. Since e does not have a numeric counterpart, it will get converted into a value called not a number, which is a number technically, and then it will get multiplied to 3. So these operators like the multiplication operator, the modulo operator, the plus, the postfix and the prefix operators are the operators that prefer number data types. So whatever operands that are there will get converted into numbers. Then there are operations that prefer string data types. So if we talk about an operation called string template, this particular operation prefers string. So anything will get converted to string. So here true got converted into a string, and then we would get to see this thing. Now let's clear this thing and think about how JavaScript convert one value into either a string or number. So it actually uses a function called toPrimitive. Now this toPrimitive is defined in ECMAScript specification, and it guides how JavaScript should go about converting one data type into the other data type. So this toPrimitive method has certain stages to it, certain algorithm to it, and by using this algorithm only JavaScript arrives at certain conclusion. So this toPrimitive method converts any value to its primitive value. Now what do I mean by primitive? JavaScript has these many primitive data types. So whatever data type that is going to go through this toPrimitive function is going to be converted into its primitive value. Then this primitive value will eventually get converted into either a string or a number. Let's see how this two primitive function works. So this two primitive function gets two input. The first one is the data type that needs to be converted, and then the hint. Now hint tells what type of conversion should be preferred. Should it get converted into a number? Should it get converted into a string? Or should it just not prefer anything, which means that it is neutral. So the hint will actually guide whether anything will get converted into a number or a string. So let's see how this algorithm works. So if the input is an object type, that in that particular case, find if there is a two primitive method defined on this. In most of these cases, this two primitive method is not defined. If you want to, you can define it, but we are not going to go into this thing because this thing is really rare. People do not do it generally, and most probably you will also not do it. So if this two primitive function is not defined, in that particular case, it will see whether the hint is default. If the hint is default, the hint will be set to number. So now you know that the hint is going to be either number or string, because the default hint gets converted into number. Now it calls this function ordinary true primitive. So, and this function actually guides JavaScript how to convert an object into its primitive value, and then it will return its value. If the input is not an object, then in that particular case it is going to be returned because the value is already primitive. So this function has two arms. This is the first one where the input is an object, and this is the default one. Moving on to ordinary to primitive. Now let's see how this ordinary to primitive works. So we now know that the hint is going to be either string or a number. So ultimately the value of an object is going to be either a number or a string. If the hint is a string, in that particular case, it is going to prioritize the two string operation. If the hint is number, in that particular case, it is going to prioritize the value of operation. And then what is it going to do? It is going to invoke that particular preferred operator on that particular object. So if we have something like this, let B, and I already have it typed here. We have this object called B, and there are two functions defined, value of and toString. The value of returns 1 and toString returns B. In that particular case, if we do something like B plus, not plus, into 2, in that particular case, we will get 2 as an answer, because we now know that this particular operation prefers numeric data types. This one is already a numeric data type, so this needs to be converted into its primitive value, which means it needs to be converted into a numeric value. So for that, it will invoke two primitive method. It will see that whether this two primitive is defined or not, because it is already an object. Since we haven't defined this two primitive method, it is going to come down here. Okay, the hint in this case is going to be number, because this particular operator multiplication prefers number, so the hint is going to be number. So the ordinary to primitive method is going to receive the input, that is B, and the hint is going to be number, and it comes down here. And since the hint is number, it is going to go inside this arm, and here it says that the value of operator should be preferred. Since we already have a value of operator, it will be called, and the value returned will be 1. Hence B will get replaced as 1, and then this particular operation will become this operation, and hence the answer is 2. So this is how everything gets converted. Let's also do one thing, true into 2. Again, the answer is 2. And how did this true got converted into 1? It is due to these two functions, two number and two string. So if we are dealing with things like converting something to its numeric value, JavaScript will invoke this two number, and if we need to convert something to a string, it will call this toString method. These two methods define how any value should get converted into number and string respectively. So if you see the language specification, it will show you how anything should be converted. It shows that if you are going to provide undefined, it is going to return not a number. If you are going to provide it with a null value or a false value, then it is going to return 0. We can see that if we invoke this number and then if we do this undefined, it is going to return not a number by the virtue of this particular conversion table. So that is how JavaScript knows how to convert something to a number and something to a string. Now let's talk about the operators which do not have a preference. We have seen the operators that prefer number, we have seen operators that prefer string. Now here are the three operators which do not prefer anything. So in this particular case, the hint is going to be default, which means that we have seen this toPrimitive method which is responsible for converting any method into its primitive value. Now in this particular case, for these three methods, the hint to this toPrimitive method is going to be default. These three methods do not have a preference. In this video, we are going to talk about the addition operator and the lose equality or the double equal to operator. We are not going to talk about the less than operator because the algorithm that guides how to carry out the less than operation is quite complex. It is not feasible to cover this algorithm in a video. If we are going to cover this algorithm in a video, it is going to make the video very big, and on top of that, it will have diminishing return because you are not going to keep it in your memory anyhow. So that is why we are only going to stick to the first two, because these two things made up most of the gotchas or the interview questions. So if you can memorize these algorithms or just simply understand how these algorithms work, you will be able to solve majority of the type conversion problems in JavaScript. So let's start with the addition operator. So if I do a string 1 and 1, not this one but this one, the answer is going to be 1 1. So this sort of type conversion is guided by this particular addition algorithm. Now I have taken this algorithm from the same document itself, but I have done one thing. I have converted that actual specification into pseudocode so that it is easier to understand even for the new people. So let's see what this algorithm is all about. So it says that first of all, convert both the operands to primitive. These two values are already primitive because this one is a number, this one is a string, and both of these data types are primitive data types in JavaScript. So we are good to go. The step 1 is already ensured. Then if any of the operand is a string, then convert the other operand into a string. This one is a string, so now we know that it is going to go inside this arm. So this one will also get converted into a string due to this line, and then concatenate the operand. Then it will concatenate these two, and hence we will get this 1 1 as the answer. Otherwise, if none of the operand is a string, it is going to go here. It says that convert all operands to numbers. So if we have something like true plus 1, in that case, it will come down here. The true will get converted into its numeric counterpart. Now, in order to convert this true into its numeric counterpart, it will employ this toNumber method as we have already seen. So it will do the implicit conversion, and the conversion will result into a value of 1. So this will become 1 plus 1, and hence the answer will be 2. You can also do the explicit conversion. So if you do something like this, number true, and you will get to see that the value is 1. So this is explicit conversion and this is implicit conversion. Okay, so again the answer is 1. So if I add 1 to 1, the answer is going to be 2. Okay, if the operands are inconvertible, which means that you try to do something like symbol and plus 1, in that particular case you will receive an error as per this arm, because symbol or big int cannot be converted into numbers. That is why you receive an error. Otherwise, just simply add both the operands and return the result as we are seeing over here. This addition algorithm is really simple to understand. Now if you want to memorize it, it is also okay. If you do not want to memorize it, you can always fall back to the ECMAScript specification, because things are going to be documented on that particular pointer. So you can always go back and see for yourself how that particular algorithm works. Let's carry out a hands-on. Let's pull out B again. So B is an object where these two methods are defined, as we have already seen, and this was the implementation of B. Let me show you again. Okay, so if we do something like B plus 1, the answer is going to be 2. Why? Because here, by the virtue of this algorithm, this one is a numeric value, this one is an object, hence it is not going to go into this arm, it is going to go into the else arm. Here b will get converted into a primitive value by using to primitive, and to primitive will receive hint as default because this plus operator do not have a preference, or you can say it is neutral, so the hint will be default, and we know that the default hint gets converted into a number, hence b gets converted into a number. So b will get its value from value of, because this to primitive will call ordinary to primitive and the hint is number, hence this value of operator will be called. So b will become 1 and then plus 1. The answer is going to be 2. Let's do b plus this string and the answer is 1e. So again, let's carry out the same addition algorithm. Here this thing is a string, so by the virtue of this arm, b will get converted into a string value, and for that it will call the to primitive method. Now in this case as well, this plus operator is a neutral algorithm. It does not have a preference for either a string or a number, so the hint is going to be default in this case, and we know that the default string gets converted into number. So the ordinary to primitive method will receive the hint with a value number, hence b will be converted to a number and not a string, hence this will be the intermediate representation. This 1 will get converted into this one due to again going into this arm, and hence the answer. So that is why I told you that eventually everything will be converted into either string or number. There might be certain intermediate stages because these algorithms will be invoked again and again, or you can say there will be a recursion. So there might be some intermediate values to the data types, but eventually every data type will get converted into its string or a numeric value. Let's talk about the lose equality operator. Let me clear this screen. The lose equality operator is this thing, double equal to, and if we do something like 1 double equal to 1, the answer is true. So let's see how this lose equality works. Now you can pause this video here in order to have a good look at this algorithm, but this algorithm has many arms to it, which means that there are many conditions here which can be hard to keep in memory for the long term. So it's better to just simply have a look at this algorithm and get some basic idea about how this thing works. Let's start. If the operands are of same type, it is going to do the strict comparison. So if we do something like 1 and double equal to 1, in that particular case, by the virtue of line 1, it is simply going to do the triple equal to conversion under the hood. I mean not conversion but operation, equality operation under the hood, and it will return the answer. If we are comparing null and undefined, now we can interchange the position as well. In that particular case, we are going to get true as an answer because these things are comparable as per this algorithm. We can also do null equals to null and the answer is going to be true. So any of these can be on any of these sides and the answer is going to be true. If you're comparing string to numbers, then in that particular case, the string operand is going to be converted into a number, as we have seen here. Now this algorithm uses recursion, which means that first of all it converts the value into an intermediate value and then it calls itself again with the revised value. So that is why I have mentioned these X code and Y code, which means that X or Y, whatever was the string, would get converted into its numeric counterpart and then it would be refed into this algorithm again, and then it will again carry out these operations accordingly. Okay, now if we are comparing big int and strings, in that particular case it will convert the string into big ints. If it cannot convert a string into big ints, then in that particular case it will return false. So if we do something like 3 and then triple equal to big int 3, the answer is going to be true because the string got converted into a big int. If we do something like e and then triple equal to and big int 3, the answer is going to be false because in this particular case this string will get converted into big int, but since this is not a number, it will result in this not a number thing. E will get converted into not a number and not a number is not equal to big int, hence we will get false. Otherwise, the string will be converted into big int and refed into the same algorithm. Then if we are dealing with booleans, the boolean operand is going to be converted into a number, and then that converted value will be refed into this algorithm again. Okay, so if we are doing something like true and then 1, in this particular case this true will get converted into its numeric value. So you can notice an overall theme that most of these things are getting converted into their numeric values so that the comparison can happen. That's why I said in the start that everything ultimately gets converted into a string or a number, because that is how JavaScript can actually compare the two things. All of these complicated data types are getting converted to either string or to numbers. Now moving on, if the operand is an object and the other operand is any of these things, in that particular case the object is going to be converted into its primitive value. Let's do one thing, b double equal to 1. The answer is true because here b will get converted into its numeric value, because this thing does not prefer anything, so the hint is going to be default. B will be converted using toPrimitive. toPrimitive will get invoked with the default hint. Since the hint is default, it will be set to numeric, and then ordinary toPrimitive will be called on b. Since b is called with the numeric hint in ordinary toPrimitive, the value of operator will be invoked on b, and then b will get a primitive value of 1. B's new value 1 will be refed into the same algorithm, and then it will arrive at this very first line, and this very first line will match because now 1 and 1, both of these values are of same data type, of numeric data type. So now it can use the triple equality operator on it, and hence we get true as the answer. Now if we are comparing number and big ints, in that particular case, if we are comparing a non-finite value like not a number, infinity or minus infinity to any big int, we are going to get false as an answer, because it is logical as well, because if something is not finite, then how come it can be equal to something finite? So in that particular case it is going to go inside this arm if the numerical values are same. So if we have something called 4 and then comparing it against big int 4, and since the numerical values are same, we get true due to this arm. Otherwise we are going to receive false. If it is not going to go inside any of these arms, then the answer is going to be false. So this is how it works, and here are a few more examples. I have listed that 0 double equal to an array. The answer is true, because if we do number and empty array, the answer is 0. Now you know the basic concepts of how type conversion happen in JavaScript and what all stages are involved and how to reach on a conclusion logically. So I hope that this video was helpful for you to understand the nitty-gritty details about how type conversion works in JavaScript. In case you want to see more such stuff, make sure you leave a comment on this video that I want more such stuff, and give this video a thumbs up, and just have a good time learning JavaScript.